My name is Rick Claus. We are here in 1A. For those of you that haven't picked up yet on my Canadian accent, this is the Canadian room, because we are known for saying A at the end of all of our sentences, eh? So this is Arena 1A. And we're here to be talking about Server 2012 R2. I'm excited. Are you excited? The keynote yesterday, we're talking about the speed and the pace of change, and you have to be there, and everything is all going so fast. You have to basically just kind of grab on and get in front of the ball and run with it. I'm trying to throw in some rugby analogies, but I don't know. You guys don't throw forward, right? You have to throw sideways and backwards for rugby. I'm here to talk about Server 2012 R2. It is an introductory session. It's going to be a bit of a challenge just because there's so much stuff that's in there that we did over the last year. We've been pretty busy down in Redmond. In the plenary session, Mr. Woolsey and Mr. Armstrong had a fantastic graphic that I really like because it kind of explains this whole cloud thing from the perspective that we're using at Microsoft to try to explain and to talk about the way that we're positioning our products. And it kind of takes it out of the realm of being more of a marketing term, cloud, and into something that we can all understand, I hope. This RF connection on this clicker is, you have to like hold it or something. I guess I'll stay on this side. He used the analogy of a three-legged stool and the concept of basically having a private cloud where you're going to be able to use your on-premise software, your existing assets, your existing hardware, and use Server 2012 as your operating system, or Server 2012 R2 as your operating system, managed by System Center 2012 and 2012 R2. And then you obviously are able to go ahead, this is hilarious, you then have to go and examine and look at the possibilities of looking at public cloud infrastructure and how you can burst out to that public cloud infrastructure. And then finally, partners and service providers. The part that I really liked about all this analogy that he had was very simple terms that are like equivalents or compatibles, if you will. For private cloud, he chose the word control because it's on-prem, it's inside your brick and mortar, you have it, you can touch it, you can see it, you can hug your servers at night if you want to. On the public cloud, he talked about, I forget the exact word that he used, but basically scale. The ability to go through and, as required, tie this infrastructure into your infrastructure, still have control over it, but then burst up into that area when you need to be able to spin up a project very fast and to be able to use those resources. And then the last one under service providers was, see, now I'm completely blanking on that third word that he used. The first one was control. Second one was scale. And that third one, the example that he was using was basically keeping it within country, keeping it by an Australian administrator, keeping it local inside your environments. Compliance. Yeah. So it doesn't roll off the tongue as much as the other two. Anyway, it fits. The idea of you being able to go off and to partner with different partners that are here in Australia and other areas that you happen to be working in, to be able to go off and to use those. That's very near and dear to my heart, being a Canadian, because we like to keep stuff north of the 49th parallel in Canada by Canadians in Canadian data centers, and that's now possible. And he also mentioned that we're the only ones that can offer all of these services together because we have the same consistent platform across all of them. You can add a virtual machine running in IaaS on Azure into your local server manager console if you want to go off and manage it just as if it was on-prem. You're able to do the exact same thing if that service provider happens to be here in Australia to be able to manage it, just at the very basic core level that I can grasp and understand as an IT pro for how that works. And again, if you have anything that you're able to look at this week, take a look at those integration pieces that you'll see from different sessions of bringing public cloud into your infrastructure, bringing hosting clouds into your infrastructure easily using Windows Server and using System Center, because it's always best to be the person that's knowledgeable about it, that can give a constructive criticism and constructive ideas on how to integrate it better than to be the naysayer and block it, because they'll just go around you, potentially, as an IT pro or as a developer or as anyone that works in the IT industry. Better to be informed and know what's going on. Lots of great sessions here all this week. And then he also brought up the important part, which is obviously the bottom, the fact that because we are using the same operating system, the same capabilities of virtualization, the same management tools, the same development suite, the same data, the same identity across all of these different portions of the cloud, or the 3 clouds, it's a consistent experience, ease of use, ease of administration, ease of integration, all the way across the board. No one else can do that. So if you don't know, it's my 3rd time at TechEd Australia. I'm good friends with Jeff Alexander, and we have been known to consume a few adult beverages over the course of the week and the months and the years over the last 6, 7 years that I've been at Microsoft. 7 years I've been at Microsoft. And he was telling me that, there's so much stuff that we've been doing across the world and within our products, and that he's been doing down here in Australia with Maca and with others at Microsoft, that a lot of people still don't even know what's in Server 2012 from a year ago, yet alone implement inside their environment. So I thought it'd be good to start off the What's New in 2012 R2 session with a quick recap of stuff you might have missed if you blinked. See the tie-in? Huh? See that? From last year's TechEd. First off, massive scale. I'll also set this up in context for what's changed with 2012 R2 as well. Massive scale. What is different and what is up there with our environments right now? Of course, I forgot to stop my timer, so I'll restart my timer there. Obviously, with the 2008 R2 environment, we had 64 logical processors. We had 1 terabyte of RAM on the host. We had 512 virtual processors per host. Very basic stuff, and that was from 2008 and 2010 before, compared to now. 2012, we bumped those up significantly, although I have not personally touched a machine that has 4 terabytes of memory in it. I sure would like to. And on top of that, we also have over 1 terabyte of memory per VM. We have the ability to have over 1,000 active virtual machines on a single virtual machine host. Inside of a cluster, we can actually get 8,000 machines running inside of a 64-node cluster. In case you didn't know, you can actually get it running on less than 64 nodes. It's a matter of do you have enough resources to run all those machines that's out there. So massive, massive scale changes in the upwards area of 4x, 16x, 32x, that sort of stuff. What this really translates into is simply unvirtualizable workloads don't exist anymore if you have the hardware. Regardless of the vendor you're using, if you're using Hyper-V, if you have the hardware, there's basically nothing we can't virtualize anymore. So we've taken care of that compute side of things that is out there. We also can not only handle the massive scale and size of those machines, we can handle the performance with our virtual HBAs and other technologies to be able to get access to the IOPS per second that is in there. The ability to go through and basically have as good as native on the hardware performance down to the disk, multiple HBAs to have access to massive amounts of IOPS. This one here is a quick screenshot of a demo from TechEd North America with over 1 million IOPS off of a single VM talking to I think it was an 8K workload that was up and talking to 1 tray of SSDs on the, in that case it was a SAN, an EMC SAN. To be able to get access to over 1 million IOPS out of that 1 VM. Untouchable, phenomenal, what you can do. Now, some other new stuff that's kind of interesting with 2012, we basically started to support a lot of the industry standards that were now becoming available inside the newer hardware. And we had to, as a result of this new infrastructure, also support larger things like the new file format for VHDX. The new file format for VHDX is actually very interesting. I'll be showing you some demos with that coming up in just a little bit for what you can do with the new virtualized disk format. The big thing here is that it's also able, to go scale up to 64 terabytes per disk. It auto-aligns with your SAN environment if it's on a SAN, which is very handy for performance, and also has major performance improvements as well. You have the ability to connect up with the virtual fiber channels or virtual HBAs, as I mentioned. I believe there's actually a session here on ODX transfers, which means that we allow the SAN to do the work of moving data, copying data, as opposed to having to bring it down and back up again on the HBAs from a VM perspective. The ability to do trim and unmap automatically to reclaim unused disk space. And also support for virtual machines on a clustered scale-out file server with SMB3. That one lone technology right there is one of those things, again, as Ben mentioned yesterday, you need to seriously examine from an infrastructure perspective to be able to make your virtualized infrastructure in your private clouds more resilient inside your networking environments right now. Very simple investment. I'll also give you a little bit of a tip and a trick on how you can set this up as well during this session. If you don't have the SAN in your house and you want to play around with clustering, and you don't want to play around with iSCSI targets and that sort of stuff, I'll show you how you can set up your own things inside your lab environments. I do have to lift this up to make this thing work. We also had a whole bunch of new networking built inside the box with our extensible switch getting a lot of interest by third-party partners. The ability to go through and do, obviously, NIC teaming out of the box with 2012 across 32 different NICs if you wanted to. The ability to go through and to have metering and quality of service on those network cards. And then also the ability to do hardware offloading down to the individual hosts and everything along those lines. There has been a couple of changes I will point out in this slide because I don't have it a little bit later on. Virtual NIC teaming is able to be dynamic, or is able to dynamically reallocate paths and access to the individual files as opposed to being stuck on one particular NIC, which is a nice improvement. And some of the offloading that we now have with RSS scaling, we can now make visible inside of the hosts and inside of the guests themselves if it's CPU-intensive networking traffic that's going on. And then from a mobility perspective, we already were pretty good with doing live migrations. With 2012 R2, live migrations got even better. The ability to go through and do a live migration across servers in a failover cluster. The ability to do a live migration just on a file-based storage, because we now support SMB3. The ability to do storage migration while things are moving and running and still without having to worry about taking your machines offline. And then the ability to do what they call an SNO, or a shared nothing live migration, where you're literally migrating from one machine over the wire of the networking connection to another machine without any shared infrastructure between them besides that one individual wire. But that still wasn't enough. We needed to make some even better improvements to how we can do things. I just saw that my demo machine flipped off and is now going to prompt me for my password. We all know how well that works. So I thought I would get this resolved now. I'll sit here and keep on moving the mouse every once in a while. So they actually did a quick little demonstration, and they recorded this one here, again, because of access to hardware. It used to be that there was a limit that was placed on the system. Arbitrarily, you would set the limit for how many simultaneous live migrations. You're only limited by your individual hardware. In this particular example, across a 10 gig Ethernet connection between two hosts, you're seeing the actual movement of 40 simultaneous workloads from one host to the other host, and it takes less than 2 minutes. Now, obviously, they're 2 gig machines. You're seeing some PowerShell down the bottom left-hand corner that was used to do this. You don't do this in the user interface. You do this through PowerShell. And as you can see here, it skims through and finishes the move and brings them across, and basically they're all done in just under 2 minutes. That's phenomenal. Like, we're removing all the bottlenecks. We're doing everything we can to make it so that you have the most effective hypervisor, most effective virtualization platform that you can that's out there. And I haven't even talked about all the rest of the stuff. But that was the big things that came out in 2012. So how about 2012 R2? Part of the stuff that I do up at, I'm based out of HQ, the headquarters up in Redmond, Washington. Part of the stuff that I do is I also do online learnings. And online demos and online courses with Microsoft Learning that you can all join for free, because I know you absolutely love getting up at 2 o'clock in the morning to be able to watch them live. I do know there are some people that do that, and I appreciate if you decide to get up and watch that, or maybe you stay up late coming back from the clubs or something. But they're available on demand as well. Now, I did a session just after TechEd North America and TechEd Europe, which was around Server 2012 R2, what's new. I had my good friend Corey Hines from HOL Systems revisit and come back because he helped me out with the previous one that I did the year before. And we had a blast. We had a great time. How much content do you think is inside this particular jumpstart that I did with Corey Hines? Any guesses? Anyone seen it yet? Anybody? Well, it's available. You can see it on demand. I have the task of trying to get 2 full days worth of content into less than 75 minutes. And so I figured this is actually the fastest way. Don't blink, guys. You got to watch this. It's like Clockwork Orange. Get the toothpicks up in the eyes. This is the detailed information that we have about all the different changes and features and functionality of Server 2012 R2 inside your environment. I love these architecture graphics and everything at high speed. I wish I could talk that fast. Going through. So I suggest if you don't want to watch this particular whole thing and you want to have it in a slow, on-demand view, MicrosoftVirtualAcademy.com. There's a course up there you can take, 8 modules. They have assessments at the end of those. Go off and try them out. You can download them, keep them off for yourself afterwards, and enjoy. It's quite good. So how am I going to bring 2 days worth of content into this 75-minute session and still have something to be able to show you? And I said, well, again, probably over drinks with Jeff over the last little while, to come up with the stuff that I think is going to be the most impactful for you, the audience, here in Australia, that may not be getting all the airtime in the rest of the sessions. I'm going to show you a couple of those and bring it in. I'm tired of watching this. It's making me tired. So this is how we logically break down what is inside Server 2012 R2. In case you don't know, what we do is we have, they're called design pillars with the software product during the envisioning and the planning phases. And one of those pillars was transform the data center. And then inside of there's these things called capabilities. And inside capabilities is where you break down into individual scenarios that have technologies that support those scenarios. It's a very complex thing. I'm just actually trying to learn right now. With who's in charge of what and what that means and the planning aspect of it and stuff like that. The best part is we can keep it really simple for this discussion. I'm going to talk about the big 3 at the top: server virtualization, storage, and networking, because they're the ones that span across all these scenarios and all the capabilities as the underlying architecture and foundation for everything to do with Server 2012. I'm only going to be able to touch on a couple of things, but in my opinion, the most relevant ones to you guys on Server 2012 R2. And I'll also be pointing you to sessions that you should go off and take a look at the rest of this week when you're out there. And if you're wondering what these are incentives for people to actually ask questions that I like to bring along when I come down to Australia. Who here last year or the year before actually got one of these lovely little trinkets of gold? This is fresh, real maple syrup from Canada. This is not the flavor of maple syrup added to high fructose corn syrup from the United States. Or whatever it is you guys drink down here. This is the real stuff. And to up the ante, I even have 2 versions. I have the nice one you can hang on your wall if you want to and give to your wife. And then I have the big one, which is double in size. So both will work on an order of pancakes. That one's the best because you get extra and you can share. I actually got a tweet from someone that got one last year and he hasn't opened it yet. He's saving it. I opened it. And how was it? Delicious. Awesome. So, let's get started. Data center without boundaries. The ability to go through and do multi-tenant environments. The ability to go through and to have standardized ways of being able to manage and have access to your resources. We already talked a little bit about enterprise class virtualization. I'll talk about changes that exist in the 2012 realm of things. R2, realm of things that's out there. Some open source support, in case you aren't aware. Microsoft is actually one of the largest contributors to the Linux kernel over the last couple of years because we're contributing access for our hypervisor and our enlightenments into that kernel to allow other open source editions of Linux as well as supported versions of Linux to run better on Hyper-V R2, which means it also runs better on Azure, which means it also runs better at service providers as well. And also obviously best-in-class scale that's out there. So with virtualization, basically you asked us and you told us, look, you need to be able to reduce complexity, you need to be able to reduce costs and reduce downtime. We came back with, okay, the ability to do something called cross-version live migration. We had the ability to go through and do online VHDX resize. These may or may not sound that interesting to you, but believe you me, they're extremely interesting and relevant to you right now. Who here has deployed Server 2012 inside their environments right now? A good chunk of people that are out there. I'm willing to bet that the majority of you that are out there using 2012 right now are using it because of the enhanced virtualization capabilities. Willing to bet that. Second to that would probably be the ability to virtualize your domain controllers, because you can now virtualize your domain controllers safely without worrying about USN bubbles that are out there. So all of you that put your hand up for Server 2012, how are you going to get your stuff from 2012 to 2012 R2 when it goes GA? What's the date for GA? You guys remember? October 18th. Everybody knows that. That's when you get access to the bits to be able to go off and to deploy 2012 R2 inside your environments. Well, cross-version live migration is the way you're going to be able to do it, and cross-version live migration is something that Ben is going to be covering in great detail tomorrow. Or actually, no, maybe it's even later today. I'll check my schedule. I got it up here. I'll let you know. That's in there. I'm going to show you some VHDX resize in just a minute. You told us that you have to go through and ease up the deployment and support lifecycle of workloads across the board. So we did some things like automatic activation, the ability to do live VM export and cloning, the ability to do a live access via the bus. Bless you. I think that was someone sneezing or else someone calling the Dolphins again. What does this mean? Well, again, something you may not get. It was called it a little bit. I think Ben's going to talk about it in his session. The ability to go through and if you license and activate your Hyper-V hosts running data center, you simply have a specific key that you have to use for that guy there, and then all the VM guests that are running 2012 R2 and above, and get accessed and have a specific key. That's a generic key that you use. That generic key basically lets them know, oh, I should really check to see if the hypervisor host is licensed, and I'm good to go. The live VM export and cloning, he'll also be covering as well in much more detail than I can. But the ability to go through and say, had a problem with this VM, something's going wrong, I need to be able to go off and troubleshoot it, but I don't want to touch the live data because it's still running. You can, as it's running, export as it's running. Take that into an isolated networking environment, spin it back up again exactly where it was, and then you're now looking at that second copy of that box. Fantastic. Also as well, the ability to go through and have basically the virtualization platform for a maximum amount of agility and movement. We have live migration compression, which is awesome. It's on by default. We also have live migration with RDMA if you're using those new network cards. And then, as I mentioned already, more robust Linux support. One more note on the Linux support. What's inside and what's new in there? Dynamic memory now available for Linux distros. Very important for a hosting environment. Also, we have the ability to go through and do snapshotting of their hard drives for backup purposes, as an example. Extremely difficult task. Now we have the ability to do that on our systems. Fantastic stuff. Also, likewise, obviously managing them with System Center, great stuff that's in there. So you saw those demos they did yesterday that included a migration, and Ben was simply click on the graphical button, and it started the counter, and it started the migration of a workload that was extremely difficult. I think it was a minute and 30 seconds or a minute 25 seconds for that workload. Just, I saw that there's a tweet while that was happening. That is a live demo in the background. That's not just us picking some arbitrary numbers and making a graphic and making it move to make it look like it's that good. That's simply the front end for the migration that actually was happening. So you'll see that stuff again with Ben in his session. The best way that he explains it to me when I ask him, how do I go off and how do I talk about this live migration, new capabilities? And he says, well, really, it comes down to, do you have 10 gig Ethernet or better inside your environment on your Hyper-V hosts? Who does? Put up your hand. 10 gig or better in your Hyper-V hosts. Fantastic. There is absolutely no reason why you should not turn on RDMA offload or accelerated migration. The reason why is because you have the hardware to be able to do it. If you have less than 10 gig Ethernet connectivity between your hosts, that's when you basically just use the compression side. And really, you can still fall back to the regular one if you wanted to, but that would only be really if you're facing some CPU constraint issues that are out there. Now, Gen 2 VMs is something that's rather interesting. And again, if you think about it, virtualization has been around for a very long time. Someone actually gave me a book on virtualization as a joke when I was speaking up in one of my cities that I was visiting in Canada. And it was everything you need to know about virtualization, and it was written in 1972 for one of the IBM mainframes that he happened to have access to. He dug it out of his storage closet somewhere. So virtualization has been around a very long time. And when we do virtualization, because we approach it from the perspective of the guest is basically a black box, let's present the most compatible version of a black box that can run almost any operating system. So it has to have an ISA bus. You guys remember ISA cards with the dip switches for the IRQs and stuff like that? We support it if you wanted to within the VM guest. It has ISA bus. It obviously has the requirements to go off and to use legacy network adapters to be able to boot from Pixie. It has the ability to go off and to have IDE controllers that don't support hot add and remove of drives, all that sort of stuff. That's all in there. Well, Gen 2 is something that came around basically because, well, we don't need that anymore with modern operating systems. So why have all that legacy garbage that's there? It works a little bit on the performance side to make it better and faster, meaner and leaner. It also works from just a simply security side because there's less stuff inside that box that you have to worry about. Is it secure and is it ready to go? It also opens up the door to be able to use UEFI BIOS and boot control for secure boots. So fantastic stuff that's in there. This is my first crazy demo to show you. And I need to hit this and go there. And there's the switch. Beautiful. Okay. How to make a new Gen 2 VM? Very simple. New machine. Hit next. I get there and type. Let's go. Ooh. That's interesting. Look at how fast that was. Let's just delete that one. I'm having some latency, I do believe. I just typed TechEd AU and it hasn't moved. I might need to refresh my console. Let's just show you. It's a wizard interface. How hard is that, right? Okay, here's the main difference. Take a look at this now. If I'm looking here at my system, you can see that I now basically have firmware as opposed to BIOS on my system that's there. I also don't have any IDE controllers anymore. It's in there. And I've got a network adapter. And that's really kind of about it. It's in there. That's interesting. That's one option of being able to take a look at it. You still have the same capabilities to go through and do your NUMA settings if you have a high-end hardware that you want to match up to, and also compatibility to do stuff. The question I get about Gen 2 and Gen 1 VMs, will there be a conversion between the two of them? I haven't heard of one. I'm not on Ben's team. I don't know if there's any magical surprises coming. That's something to ask him in his session. I would find it highly unlikely because you're changing the massive architecture between those two VMs that are in there. Obviously, it's also going to introduce some interesting migration capabilities. Can you migrate a Gen 2 VM from 2012 R2 down to a 2012 host? 2012 hosts don't support Gen 2 VMs. So Gen 2 VMs, they're definitely there. I'd show you to make one, but for some reason my typing isn't working right now, so I'm not going to. If I actually go inside that Gen 2 VM, let's see if it works inside this guy. That is wild. Oh, there we go. Phew. So this was just a sysprepped image that I had. And because this is a brand new sysprepped image, obviously the resolution is kind of gross, so let me fix that resolution for you. Make it full screen. Okay, so Gen 2 VM, basically it looks the exact same as any other server VM I've ever made. The fact is, it's now simply a Gen 2 VM. If I use my lovely Windows key X administrator shortcut key to go to Device Manager, you'll see here that basically I have a reduced set of information that I have to worry about. Hyper-V networking adapter. Information as far as how things are basically chained and working on my individual system. Very simple, very clean, Gen 2 VM. Give it a shot. Have a take a look at it. I'm going to save the resize for just a minute and come back here. and go. The big thing that is very important about Gen 2 VMs is obviously the ability to go through and to do a Pixie boot to be able to do OS installs. It's supported out of the native adapter. You do not have to worry about doing legacy adapter just for the purposes of Pixie booting. It makes deployment very, very fast if you already have a WDS solution or imaging solution out on your systems. Now, the online VHDX resize, this is one that came up as a good possibility of something that you guys would find interesting and useful inside your environments right now. The ability to go through with an online VHDX resize basically gives you the ability to expand your virtual SCSI disks, to grow them and to shrink them. And you know this is made by someone from the Commonwealth because they use the word whilst attached to a running virtual machine. You then are able to go in and basically grow the file, and then you can expand it within the guest. You can then go and shrink the file at the hypervisor level, and then go ahead and shrink it within the guest. Let me show you this just from a perspective of how this works. Hopefully my thing is there. It's good. And I did it on this guy here, so let me bring him up, get him ready to go. Okay, because this is not a new VM, I actually have to zoom it so you'll be able to see what I'm doing here, which is important. You can see here I have a disk number 3, which is a basic disk, which is 50 gigabytes in size, and I'm looking at it right there. I'm going to make this window so you can see it on both sides, on one side of the screen. On this side of the screen, at the hypervisor level, I'm able to go in here and choose my hard disk in question. To do this, your shared VHDX file has to be a SCSI attached disk that you're going to be attaching to. This just happens to be a Gen 2 machine. It doesn't have to be. It can be a Gen 1 machine. And then on that particular guy, I can, while it's running, hit Edit for that particular one, hit Next, and I can say Compact or Expand on that particular disk. This is going to simply, again, change the file size of the virtual hard disk to make it smaller, or change it or expand it to make it larger. If you remember, it's 50 gigs. If I say expand, you'll notice that by default, it's trying to go in and tell me 51 or above, up to 64 terabytes. I'm going to go up and say 200 gigabytes. Hit Next, hit Finish. The magic of demos, it's done. If I go back and show you that particular file server now, doesn't look like it changed much as far as he's concerned, but once you hit the refresh and it rescans the disks, you'll notice down below that partition has now been, that drive has basically been extended to be larger on my system. Yay, golf clap, anybody? Now, to save space and save time, at the hypervisor level, I'm using a dynamic disk. The same thing could be done if it was a fixed disk running a workload. It's there, and you can reclaim physical space on your system. Now, I'm going to give you one more quick little tip coming back here. This is back to this guy. I'm going to hit Settings on the main guy. Here's the resizable drive. I hit Edit. Nothing's different there. And now what I want to do is I want to go in and I want to say Shrink this guy. Hit Next. And then what size do you want to make it? Let's make it 25 gigabytes. Notice it says, out of bounds. I want to go down to 50. Here's your tip, in case you're trying to figure out why this isn't working. The file system of the disk that you are expanding or shrinking has to already be known to the operating system with a known file system, like NTFS as an example. If you left it as raw disk, you would not be able to shrink or expand it because it wouldn't know where the data is on that disk. So because it was already formatted and had a partition on it that was 50 gigs in size, it knows there's 50 gigs worth of data potentially on that drive, so it's not going to allow you to go down below it. So whenever you're playing around and trying this out inside your own environment, make sure that when you add in a virtual iSCSI disk or virtual SCSI disk into your environment, that you put a format of a file system on there. So I can bring him back down to 50. If this was a fixed disk size at the hypervisor level, I would now be able to reclaim 150 gigs away from the system to be able to use for somewhere else. Now if I go back in here to my client machine, hit resize or rescan, you'll notice that it comes back again just to the 50 gigs. That's a resizable VHDX file. Pretty cool. Now, some other stuff that we have, some other innovation going on. I think I'm going to absolutely let you go through, and by all means, please go and see Ben's sessions on virtualization. He goes into far, far greater detail than I am here on a lot of things that are in there. Now we're going to talk a little bit about some new innovation that we have inside of our environments for storage and also for software-defined networking and other things like that. We've basically taken our learnings from the public clouds we've been working with, and we're bringing them into the operating system so you guys can now take a look at them. I was at a BIG user group up in Brisbane on Monday, and we're talking about the speed and this pace of change that we're going through right now. And the fact is, in case you haven't read the writing on the wall from yesterday and also from what you're going to be seeing the rest of this week, as IT professionals, we no longer can sit back and basically choose, I am going to standardize on this server OS for all of my servers, and I'm not going to upgrade to any other new versions until we are ready to go with everything again. Same thing with desktops and that sort of stuff as well. Don't worry, though. We're not going to leave you hanging. All the stuff that we're going to be doing and the new innovations that we're bringing into these new versions that are coming in case you haven't noticed with 2012, we're not coupling them to specific Active Directory domain versions, as an example. We're not tying them to different force functional levels. We're trying to make it so it's easy to move your data between them, because that's the hard part, is how to manage the change that's in there. We're just asking you to get up to the current version, which is the entryway to this new platform, which is 2012. And then when you're ready, start to inject and bring in 2012 R2 into different areas. You'll manage them the same way. System Center, Server Manager, PowerShell, from your admin workstations. But you'll be able to take advantage of the different pieces of those technologies we're bringing into there from whichever scenario you need to have access to them from inside your environment. And so, I'm a huge fan of storage. I did a session last year, extremely popular. I think it was might have been the top session that I did last year on storage and storage spaces and what you can do with it. And I know I've talked to people that have implemented the new storage technologies inside their environments already. How many people here have a SAN inside their environment? Okay, keep your hands up. How many people have more than 5 SANs inside their environment? Well, it's still a good chunky out there. Some people were tweeting and asking, do people really have different vendors and different types of SANs inside their environment? Absolutely. And so we're trying to make this a little easier that's out there, to be able to make it so you can have standards-based management across your storage, to be able to do stuff. And we have inbox offerings to be able to do some very powerful stuff with storage and how that works. And so people are saying, well, geez, I love the stuff that I'm getting from my SAN manufacturer. It's all fantastic. Why would I think about considering changing to using this stuff? Again, the learnings that we have from working inside these large public environments, these public data centers that we run. There are no SANs in Azure. There's no SAN inside Amazon. There's no SAN inside Google. It's too expensive, too complicated, crazy to manage at scale. So how do they do it? How do we do it? Well, I can tell you how we do it, because we make the OS and we work really hard with different industry vendors to be able to come up with these technologies. It's not just us. It's industry standard stuff. But I thought I would first of all demystify a little bit about storage appliances. At a large event that I was at up in the springtime up in North America, they had hands-on lab environment. I strongly encourage you guys to go and try out the hands-on lab environment here at TechEd as your hands-on learning stuff to complement sitting here and listening to these different things, because they've got some great labs that are up there. The way Corey does it here with HOL is actually there's minimal to no server infrastructure here. He didn't bring racks of servers to get stuff working. He's talking back to his data center, back in his hosting environment that he runs. At this one conference that I was at earlier, they actually had this big, massive infrastructure that was there that could handle 650 simultaneous booting of systems and multiple virtual machines per lab and everything along those lines too. $5.1 million with the hardware to get that up and working and running. Beautiful. I loved it. Lots of blinky lights. Awesome. How much of that $5.1 million do you think was dedicated to storage? Haphazard. Throw out a number. Anybody? I heard a lot of it. 80%? I need a number. 400,000 out of 5.1 million? Sir, you need to work on your exchange rate. But just because you were the first one up, I want to give you a maple syrup just for that. So come on up here. Maple syrup. First one out. See, I do give them away. $4.8 million of that implementation was storage. The rest of it was server licensing, and software. 4.8 million out of 5.1. So let's take a look and demystify some of the storage appliance. A SAN. What is actually inside of a storage appliance? Well, they have processors that are running. They're x86 and x64-bit processors that are running inside their compute area, the controllers. They have a whole chunk of memory that's in them to be able to go off and to run the operating system and to do caching activities off of those controllers. They also have networking adapters to be able to go off and to talk to each other and to talk and have clients attach up to them inside their environments. And they also have HBAs to go off and talk to the disks that are out there. See, it's pretty simple. It sounds very familiar. Well, if you look at this logically, well, here's your box, and here's what it looks like as far as the controller is concerned. And on there, you've basically got a front end and a back end. On the back end, you've got your interfaces to the actual disks that are inside the spinny, blinky enclosures that are out there. Usually it's SAS that's out there. It presents LUNs. It prevents pools of disks. It allows you to stripe down the ways that it's writing its data across those different disks to give you resiliency level and performance information. And then you got a front end that presents the interfaces to the customers, the clients. And it could be iSCSI, could be NFS, could be SMB, could be fiber channel over Ethernet, a variety of technologies that are out there. If you want to make it more highly available, open your checkbook, get another controller that's on there to be able to add it out, and another, and another, and another that's out there. Obviously, unspoken in there is obviously that those controllers are running an operating system to be able to handle all of this for obvious reasons. And then you have connectivity through 1 gig, 10 gig, other stuff, fiber channel, different arrays, different stuff to be able to have access to your workload servers going off and talking to that. That's a storage appliance. That's what it is. It's not this magical black box you don't know anything about. It's probably very familiar. What we do with Server 2012 R2 file server and spaces is that we have 2012 spaces being used as the thing that talks to the back, to the disk that's out there, and to your management interfaces. We then have the file server in the front end of that, presenting that information out. And we can use SMB3, as you'll see, which is phenomenal, industry standard way of presenting storage and shares out to people. It can be clustered. It can have scale-out file server clusters up to 8 or more nodes, being able to serve this out. And we also are able to present more standard stuff like iSCSI targets if you want to go the old-fashioned route, or NFS shares. And then you finally have your workloads. Sorry, I didn't mean to jump by that fast. You have your workloads that are attached up to it. Let me go backwards for a second here. There's the other one. There's us. Did you miss that? Here's the other one. There's us. It's the same concept. Now, when you bundle this together with the magic of software and you present this up as an architectural challenge to your partners to say, why don't you come up with some new ideas of hardware offerings? Cluster in the box basically was born with Server 2012. The concept, using Server 2012 or Server 2012 R2 as your OS on those 2 nodes, there's a server A and a server B, inside a single piece of tin that's racked inside of your server rack, as an example. You can have a 2-node or a 4-node, the current configurations. They have the ability to have a network connectivity between those 2 boxes just for themselves, for management interfaces. They have the ability to have storage controllers that has access to shared SAS backends inside the same chassis or attached through external JBODs. As long as you have multiple paths to the JBODs for both of those nodes, you can access those disks in a shared fashion. You have a SAS expander talking to your individual drives that are out there too. Now, to go past the architecture and to look at what it looks like, the demo infrastructure that I'm running my demos off of right now back in my lab is actually a data on DNS 9220. It basically is a 2U form factor, 6 drives up at the front, which is basically my JBOD enclosure built into it. And then you see the 2 nodes right and left architecturally on that individual slide. They have 128 gigs of RAM apiece. They have Server 2012 operating system on them. They have an interconnect on there for networking, for the management interface of the cluster, for heartbeat information. They have external network cards that I've teamed together for access for my clients. They have the shared SAS bus to go off and talk to the drives that are on that. They sell an additional 60 drive JBOD that plugs in the bottom of this thing, so I can have 60 plus 12, 72 drives configured inside my environment if I wanted to. Phenomenal stuff that's in there. Unbeknownst to us, our partners at Dell were actually making a really cool looking one that's a 4-node, but they were using their own hardware-based solutions to be able to do the shared SAS. Instead of spaces, they basically didn't use spaces. They used their own controllers to have access to the shared disk. Fine, it's a cluster in the box. It's great. It's called the Dell VRTX. Very sick and very cool looking. And likewise, I have a second box that's running up there in my data center environment, and that one there is one by Quanta. And that one there is actually using an LSI card called a Synchro. So it's a card that's doing a hardware level implementation. You can go total software if you wanted to. You can go hardware if you wanted to get this capability. What does this mean? Architectural building block. That's now a cluster in a box that has a wizard interface to configure the cluster. Done. Very, very interesting. So now you're saying, okay, well, why, what sort of stuff do we have in the actual SAN environment that's out there, and how does it compare to what we do in the file server side of things? Well, on the SAN side of things, they have some functionality to do storage tiering. They have data deduplication. They have RAID protection to protect your data on those drives. They have the ability to pool disks together into different compartments. You can delegate out access to those disks. They have high availability by having clustering capabilities. They have write-back cache to make sure that you don't lose data if you lose power. They have the ability to do offloaded processing of power of copies back and forth. They have snapshots. We do too. The new thing with R2, that's the biggest thing that you saw a little bit of yesterday, is this concept of tiering. I'll actually make a tier just to show you how easy it is coming up in just a second here. But tiering is so simple to do. Very, very simple to do. And we've got it built in now, and it works at the block level of the data that's on those different drives. Data deduplication gets even better inside of our environments that are now able to reduce the amount of data that's on there. Plus, it also works phenomenal for being able to get faster access for your shared gold images for your VDI images, as an example. You have more flexible resiliency options to have 2-way and 3-way mirroring. This isn't done at the disk level, in case you're wondering. This is at the actual slab level of writing the data across the different disks. The reason why we're going at the slab level as opposed to disk level is it gives the ability to do parallel rebuilds to get the drives back up and online again faster, because you can take data from multiple sources to make those drives get repaired faster. We also have write-back cache, some offloads, some snapshots. Basically, we're good to go with what it is. It's in-box, doesn't cost you anything different as long as you're using the proper hardware. The caveat that I will say is basically spaces-compatible enclosures are required, spaces-compatible controllers are required, and that's simply a matter of do they have the Windows logo and have they gone through the certification process. So this tiering piece, what does it mean? Well, very simple. I got some questions about this when I was up in Brisbane, so I'm anticipating some questions here. I have maple syrup to give away if anyone asks some questions. Let me bring up my remote control to the proper box before I switch over. Okay, we're good to go. This is the data on DNS 920 or 9220 box that's out there running right now. It has Server 2012 preview bits on it. And I have my drives. You can see here that I have, as it slowly zooms in, I have both SSD listed. I have 4 of them. Those are enterprise class SSDs. And I have HDDs. Notice the sizes, a 2 gig SSD, enterprise class. It's a good price point. You can buy those. Yeah, I'm not going to say they're the same as if you go down to, what is it, Dick's Hardware or something like that? Dick Smith's, go buy a couple of SSDs. It's not the same, but I will say. If you decide to go down that route, those will basically burn up and melt after a couple of months of use as a server. So go for the enterprise class ones. And then you've got a bunch of HDDs. First off, when you make a tier, the tier is only available between SSD and HDD. It does not care if it's a 7200, 15,000, or 10,000 RPM drive. So dollars per IOPS and dollars for performance, it's actually more cost effective and more performant if you stick with good quality SSDs that are enterprise grade and then just go with high capacity server class 7200 RPM drives. You could go with 10,000 RPM drives, but you're going to pay more for the same capacity. and you're only going to get a marginal increase in performance, because the performance increase comes from the SSDs. Same thing if you go with a 15,000 shared SAS drive. You're paying big bucks for a 300 gig drive. You're almost at the SSD price range in that case that's out there. So you can only do this between spindles and SSDs when you do it. Now, I'm assuming you guys have seen people make a pool before. All you do is you simply say right mouse click, new pool, and then you would simply select the disks in question, and you're done. Same thing. I'm not going to bother showing you that because it's already made. What I do have down here is you basically have to go in and assign a new virtual disk as part of that new pool. So my pool's been created with a mixed variety of different types of drives. So I'm going to use my demo pool. I'm going to call this one here TechEd AU disk. Notice that this little box, checkbox, is available to be turned on. If it does not detect a mixture between SSD and HDD, it's not available to turn on. There's a phenomenal blog post that I'll show you at the end that Jose Barreto has written up that teaches you how you can do this in your lab environment, in your own house, your own home, your own training capabilities, or inside your lab environment at work, with only using a locally attached consumer-grade SSD and a spinning drive to actually show the differences in performance of how tiering works, in case you want to get comfortable with it. Very simple stuff. Absolutely not supported in production, but simple stuff to do in a lab. So I'm going to turn on my checkbox for a tier. And then this is a bug in the UI because I do not have the final code. So you should not see, you're not seeing double here. There should only be a simple or mirror, and that's it, not 4 versions of the same thing. I found that rather humorous. And then you have either a 2-way or 3-way mirror that you can choose, all based on the number of disks that you have available in your pool allocated to it. You can obviously survive more than one drive failure if you go with a 3-way mirror. I'm going to go 3. The next thing is you'll notice that you do not have the ability to make a thin provisioned. Save on the drive space, use a thin provisioning. You can't do a thin provisioned tiered storage space, only fixed for obvious reasons. And you just know where the different tiers are and where the data set happens to be. So fixed is the only option to be able to do this. And then it comes up and says, how big do you want to make this tier? It scans the drive, sees what's available. Oh, there's some pool information that has an issue here. So let's go in here and just say, I want to make this guy 20 gigs in size for my faster tier and 100 gigs in size for my standard tier. Or I could just choose maximum if I wanted to. A virtual affected disk space is 120 gigabytes. And it's not going to let me continue because it couldn't scan my other system. Well, I literally hit next and it closed. And it's done. So that's the interface for doing a tiered environment for where the system happens to be. Very simple stuff. Now, if you turn on and enable write-back cache on the system, write-back cache is the other piece that's new that we have inside of our environment. Write-back cache allows you to basically use a portion of the ultra-fast SSD drive to be able to have write-back cache in case, again, there's a problem with performance, a problem with power. You can put stuff on the write-back cache to make it go faster. I'm going to save that demo as one of my things I'm showing you on Friday to be able to entice you to come to my storage session where I go into more depth and more detail on that. Wow, it's early in the morning. You guys are all so quiet. You have no questions. Either that or I'm just doing a great job in answering all your questions before you can ask them. Oh, I heard a question.
For people who have significant investment in sands, basically sands, would you be able to use the sand that's presented to your system as your hard drive?
The question is, for people that already have an existing investment in SAN technologies, could you present the disks from the SAN as a SAN LUN as your disk to be able to do your tiering and be able to do your other stuff? The answer is not a good idea. No point. It's the overhead. Continue with your investment in use of the SAN for the performance and the reasons why you have it and everything else. I'm not going to obviously be a crazy guy and up here and say, throw out your SANs, just go with server, buy all new JBODs. I'm not going to do that. If your SAN's working for you now, keep on using it. This is an opportunity to take a look at it when you're in an environment where you need to extend the capacity and you don't want to bring out the checkbook to write a massive checkbook and to buy another enclosure for the SAN environment. If you have a new project that's spinning up that needs to have new storage, go ahead and to do this as well. I'll talk more specifically around those kind of things on the Friday session. It's coming up. So don't throw out your SANs. It's all still good. And thank you for giving me a chance to plug my storage session. I'll give you a big one of maple syrup. Guest clustering. Guest clustering is something that kind of hits an interesting point. More likely if you're a service provider than if you're using this inside of your own environment right now. But guest clustering is something that previously you would have your guest VMs up in one area of space called your tenant space, if you will. And then down below you have your back-end infrastructure for things that you wanted to go off and to use. And what you would have to typically do is you would actually have to go through and have a little bit of a challenge, because once the virtual machines and all the services are all provisioned, you have to go in and have access to physical resources that are typically hidden from those individual guests. So you basically have to punch a hole through this dividing line of having access to the physical iSCSI targets that are out there on the storage side of things to do this. So it's not really a great idea of being able to do this. Guest clustering with shared VHDX is another option that you can now use with 2012 R2 and with Hyper-V as your hypervisor. Basically, the idea of being able to have your VHDX files that are on your system, and then you simply are able to go off and share them without having to present a real LUN to your tenant. They show up as a shared SAS disk, in case you're wondering. You then turn on guest clustering. You then go in and basically run your cluster validation wizard, and boom, you're off to the races. I literally made one in 10 minutes or less before you guys arrived to be able to show you what it looks like. Let me switch over to that guy before I bring it over to make sure my password is correct, which it is. Okay, so here I've got, again, my Hyper-V boxes, my cluster in a box, Hyper-V 1, cluster in a box, Hyper-V 2. These guys are the ones that are using the LSI Synchro card, so it's the hardware-based shared disk solution on the system. And I happen to have my SOFS number 1 and SOFS number 2 guests up and running to be able to go in and to make any changes to this. Let me show you here. If I do settings of the box, and under disks, all I would basically do is simply say add a new hard drive to my system. And then I already have the VHDX file already created on my system. Has to be VHDX. And I'm going to choose this guy here, number 4. I hit apply. That guy now has a new SCSI disk attached to it. Nothing fancy, it's the exact same interface you would have seen before. The difference is, down here, this one checkbox, enable virtual hard disk sharing. It's grayed out now because the machine is currently running, so that's one thing. You saw the live resizing of VHDX files that you could do, that's fine. To turn on the shared functionality of a SCSI disk, you have to actually have the machine powered off to be able to do that, to turn on that one checkbox. So that's why I did it before you guys got here. This guy here, if I take a look at the advanced settings, you'll notice that he's already turned on and the machine's already running. So if I flip over here to my scale out file server number 1 box, you'll see that basically I have 2 disks that are set up for use in my cluster environment, and they're both 126 gigs in size. If I go off and actually run my, make this full size, failover cluster manager, you'll see here under storage and under disks, I have 2 disks that are already up and working. One is a witness quorum disk and one is a cluster shared volume. No iSCSI configuration, no IQDNs to be able to identify where the disk happens to be, no login authentication. This is all done at the virtualization layer, at the hypervisor layer. That also means you can script all of this if you wanted to. You don't have to expose any of your underlying infrastructure, and it can be completely delegated out to people to use and to work on your environment. So, fantastic stuff. That's how simple it is. You literally have 2 machines, turn on the shared turn on the shared disk option when the machines are offline to a common VHD file, and then bring it up and have it up and working. Yes, sir?
2 questions. So, if do all nodes have to be offline to add the shared VHDX, or can you have one node offline, editors share it, bring that up, then bring the other node down, add it to the shared disk?
So great question. The first question is basically, do you have to have all the nodes offline to be able to turn on the shared disk functionality? Do you have to be able to have one of them turned off to be able to turn on the functionality? And then as you add them, yes, they do have to be off to be able to add it. It's just think of it like it's a physical piece of hardware and you're configuring the drive bays that are in the system. Think of it that way. Second question?
Are Linux guests supported to use shared VHDX?
Do Linux guests do support of VHDX? That is something I'm not going to have to defer to Mr. Armstrong because I have not tried it inside of a Linux VM. So you caught me there. For that, I'll give you a big one. You can come to, you want to come down now and grab it? Great. I saw another person up behind you there with a check shirt. Nice shirt, by the way. The question is, can you live migrate the guest node once it's done? The answer is yes. It's a VM. You can move it wherever you want to. So long as it has access to that shared VHDX file. Obviously, that shared VHDX file has to be on an SMB3 share and accessible to the different hosts. It was assumed it was understood. But yeah, that shared VHDX file cannot just be on the local C:\VHDs. It has to be on a clustered shared volume that can go off and see it. That's out there. Okay. So basically what we did is we made a cluster out of a couple of guests. Again, interesting challenge. If someone goes off this week before the end of the week and can show me that they have made a 64-node shared guest cluster with shared VHDX, I'll save one of these maple syrups for you. Come find me in the expo hall. It's simply a matter of turning it on. Virtual disks have to be shared and present as just basic runs to the systems. It eases operations and management, provides business opportunities. Again, if you're in a hosting environment, to be able to serve up and show clustering on the systems. You'll notice there's a lot of settings that are inside Server 2012 R2 that are new, that are really targeted towards large enterprises or targeted towards service providers to provide services to their clients, as an example. And the answer is yes, that is true. There is a lot of changes that are in there. It doesn't mean that they're exclusively for them. You can use these obviously as well inside your environments. I mean, being able to create a shared guest cluster for a SQL server that you want to serve up and show to a particular project inside your environment. Very simple to set up a guest cluster now using this, and also to be able to go in and not worry about where they happen to reside. And you can migrate them to different hosts to have even better functionality for your system. So it's all there, it's all supported. Next section, we're moving out of storage now and into networking as we're coming close to the end, I do believe, with software-defined networking. And software-defined networking is, again, all part of this concept of having these 3 clouds that are out there that you literally just plug in and grab resources from if you need to. It'd be really stupid if you couldn't take and connect up these different systems transparently without having to re-architect and re-IP address all of your servers again to be able to make it work. That would be a nightmare. And so SDN, or software-defined networking, is something that basically allows you to go through and ensure that you have connectivity between your private cloud inside your own data center through a NVGRE gateway that we have is built into the Server 2012 R2 system, have a point-to-point gateway between that and Azure to be able to have seamless connectivity, and have the same IP address range as what you need inside your own host environment is up there, and then down to your service provider as well. This also gives the ability to have VM mobility. That doesn't mean you can do a live migration from your on-prem cluster to the server up in Azure. You can't do that. But you can take a live export, because that's now supported, and then bring it up into Azure, upload it, and then have access to it and spin it up if you wanted to. Or same thing to your service provider. So this software-defined networking allows us to be able to offer something like this across all 3 of these different areas. Why network virtualization? Some great ideas. Obviously, the ability to go through and to not have to worry about managing your 5, 10, 50, 500, or 1,000 or 2,000 VLANs inside your environment to isolate your different workloads right now, to basically simply go in and through and use industry standard technologies with NVGRE encapsulation to go through and have access to those different systems with the same IP addresses. In this case, you actually have blue company and red company. You know, I never thought I should have changed this. I could have used rugby team names or something. You have the All Blacks on one, you have the Wallabies on the other. They too should not exist on the same network, but they have to. You could go through and have blue company, red company on the same systems that are out there. Easing of management, the separation of control, and also the ability to go through and to provision and work with these guys and not have a subnet as your boundary anymore. Centralized management of the control plane. We had a discussion again at the BIG user group talking about the concept of how System Center Virtual Machine Manager is kind of changing very much into a fabric management. You manage your virtualization layer within SCVMM. You manage your software-defined networking within SCVMM. You manage your storage and build storage servers within SCVMM. If you haven't kind of caught on to my repetition of the word, you should spend some time playing and working with SCVMM to be able to take advantage of all these different capabilities. Live migration across subnets, breaking the VLAN scalability limits, merging networks onto the same fabric, even with overlapping IP addresses and how that works. And again, NVGRE, I don't think there's a session on SDN here. I'll double check the sessions coming up here. But it literally is, think of it as the old days of how you would take and analyze a packet coming from a single host over across a network to another host. If you understand TCP/IP with headers and networks that are host identifiers and that are network identifiers and the packets and how those different things work. Same kind of concept, except we're inserting in a provider layer that's in there, and we're also building into the software that's running the system the ability to go through and know the different rules of who can talk to what on the different systems. So with software-defined networking in 2012, basically it's open, it's extensible, it's standards-based, that gives you the ability to go through to move your systems across the world that you need to, while keeping the separation as far as the guests are concerned that are working with this. And it also spans physical and virtual. I don't know if you got that from the keynote yesterday, but one of Ben's favorite thing that he liked is the Arista switch as an example. It's a top-of-rack switch that's actually running a Linux embedded on it that goes through and controls the ports. And you need to go off and to manage that. Well, Arista has gone through and partnered with us, and they've implemented an OMI, Open Management Infrastructure Standard, way of managing their ports that you can query with PowerShell. Turn ports on, turn ports off, isolate ports, bring them together, group them together, team them together. Whatever you need to with their switch can all be done with PowerShell. Plug that into SCVMM. You now can manage the virtual switching layer within the hypervisors across all your Hyper-V hosts, and you can now manage the physical infrastructure of your data center across all of your hosts as well. Phenomenally powerful stuff with software-defined networking. Inbox multi-tenant edge gateway capabilities, and also the ability to go through and do some self-service management as well with the SCVMM portal that's out there. Question is IPsec affected with this area that's in there? To kind of twist that a little bit differently, are we breaking encryption stuff, IPsec as an example for secure tunnels, because we're disassembling and reassembling the packets, this sort of stuff? No, we're not. We're simply adding on to be able to move it and stripping it off before the guests get to it. So there was a time when we were doing some packet rewrites. Doesn't happen. Industry standard, works across the systems, all good for where it goes. Question is, what's the overhead versus traditional networking that happens to be out there? There is obviously some. It's negligible based on the performance data that I've seen so far. But the ability to open up the flexibility of what you can do with SDN, I wouldn't care. I don't have to re-IP address all my servers when I'm trying to move them from one place to another. You literally can take a bunch of servers in the one guest network that's working and functioning at 192.168.0 network, let's say, and you can actually move them to two physically different hosts in two different data centers if you wanted to, and they still think they're on the same subnet across. They just would have some latency to get there. That's all they would know about. Recovery services is the last area that I'm going to talk about. It kind of fits in across all three of these different swaths that we were talking about earlier with business continuity, with storage, with virtualization, and also with networking. And I'm curious to find out, does anyone here currently use data center replication between two different data centers right now? For some. Very good. How many people here have gone through and actually tested their disaster recovery capabilities on a regular basis? Tested, everyone went up, and then regular basis, everyone went down again. So with 2012, we basically came up with this one inbox product. It's called Hyper-V Replica. That gives you the ability to go through and to basically create a guest VM and right mouse click on it and say enable replication, and then point to a different server inside a different data center if you wanted to, inside a different domain if you wanted to, inside a hosting partner's network if you wanted to, and then have a secure certificate authentication and encryption between those 2 points while it's replicating. You can then actually take and ship a USB export of that VM of data and then use that as the target initial replication of that VM to save you gigs upon gigs of replication across the network, and then establish a synchronization across the board. Fantastic stuff. That was available in 2012. A lot of people really liked it. The service providers, though, on the other hand, they're like, hey, can you help us out one more level with this? Because this is so awesome. How do they go about, and they now have it protected on their system. The customer is now happy that they have their data someplace else and they can spin up when they need to. How do they go off and now protect it again inside their data center to a different location as an extra layer of protection? You only had a two-way Hyper-V replica that was possible. With 2012 R2, you now have the ability to do three-way, triple replication or tertiary replication in the box for Hyper-V replica. The way to establish this is the exact same way you did the two-way replication. You simply choose the first machine, you say replicate to this other guy to enable replication, you put the target server in there, you authenticate to it, you prove that you have access to it, and then the data goes across, you're now in sync. You choose your schedule for what it wants to be. The schedule used to be 5 and 15, or maybe it was 15 and 30, I forget. It was a large enough increment of an opportunity of a window of missed data that might not be there. We've changed that, so now it's down to 30 seconds if you wanted to, for the first level of replication. Once the replica is finished to get to that second side and replication is now going and simply synchronization is taking place, you can do the third replication to another location. When you do that third replication, you can't do it as fast as the first one. 5 minutes is the smallest it goes, or maybe it's 15. I have to look at the interface because it might change on the preview. But basically, you can establish your third level of replication. So now you can go and replicate from your main data center over to your hosting provider if you wanted to, or your secondary data center. And then when that's been established, you can then go and replicate that guy to a different one someplace else. Yes, you are going to be paying for latency. You're going to be paying for moving this data across. But that is a small price to pay when you end up in a situation where you have your data center being flooded or some kind of disaster happens, unfortunately, that has affected your data center. It's in box, it doesn't cost anything, and it works really well. And you can do it to unlimited number of VMs if you want, if you have the bandwidth. You can do it to unlimited number of VMs inside your environment. Think of this as if you already have a third-party replication solution that's in there, replicating data between SANs, let's say, continue, use that, it's still there, go ahead. But that's probably only working on a very small subset of your most critical servers that are out there. Start to enable this other type of replication on the other ones that you would like to have as well. And then choose to have the replication up and running on those individual systems.
Where do you back it up? At the source or at the final target?
The question is, where do you back it up? At the source of the final target? Your choice, sir. Doesn't matter. They're identical VMs. If the target is a hosting provider, you'd have to assume that you're paying for a backup contract at that hosting provider, as an example. If it's yourself, you could back it up in both spots if you wanted to. But a good point, though, the Hyper-V replica does not replace backups for your servers that are not replicated. So still do backups on your servers that are out there. And you're kind of trapped right now, but you can come down and I'll save you one of these for that. Good question. Does replica copy C come from B or A? It comes from B. So basically, that's why you have a time delay for how fast you can get replication going from the second to the third. That's also why you're not able to establish that third level of replication until after the second level is finished in the first time. You're also kind of trapped there as well. If you come down afterwards, I'll grant you one of these guys. Question is, pardon me? Licensing. This is assuming that you have proper licensing in place. It's also assuming that you're only going to be running these replica copies when the other one's turned off. It's also assuming that you're probably smart and you're using Data Center Edition on your host, where you don't really care about licensing because you've licensed the Data Center Edition, which has your server licenses covered for you. The question is, do you have to license the data center hypervisors as well? And the answer is yes. They have to be licensed to be able to work with it. So yes. And the third copy as well, yes. One extra thing that I don't think they got a chance to show you yesterday, but supposedly you're going to be able to see this if you go to Ben's session today, is this thing called Windows Azure Hyper-V Recovery Manager, or HVR. I love it when the Australians say HVR. It sounds like they're pirates. Arr. It's out there. Picture this as your ability to go through and have an automated disaster recovery plan running in Azure, because you have an Azure subscription and you have System Center up and running inside your environment. And you have replicas taking place between your two different data centers that are out there. HVR allows you to go through with Recovery Manager and basically establish a plan for when you want to go in, and it will orchestrate the final synchronization and the powering up and the powering down of the systems between those two different data centers for you when a detection occurs or when you kick off that process, as opposed to you having to do this manually. HVR is something that is interesting. Be aware the fact that there is no data that goes and puts anything up inside Azure. It simply will coordinate those efforts and resources between the two different systems. The data is replicated down below. It's out there. The last one that I had is simply one quick little slide to talk about the fact that you can now go in and install a Windows Server Essentials experience on a standard server if you wanted to. It's no longer a separate purchase that you have to have or a separate license. It does change your licensing mode for that individual host system that you're running this off of. And it gives you, in case you're not familiar with Hyper-V, with Windows Server Essentials, the ability to do a great backup solution for a branch office, the ability to go through and have backup systems that are there, and it ties into your existing infrastructure. It's great if you wanted to have a second server inside your environment or extend your servers inside your environment without having to do a reformat. More details on that as we get closer to GA for how that works. It's very simple to turn on and turn it off. You can try it in the preview if you want to. And with that, my friends, it is time to go through, you've seen this before, reconsider and take a look at the fact that we have a hypervisor solution and virtualization and the management suite and tools and experience to virtualize any workload you can throw at it. Seriously think about rethinking your storage solutions for how you need to go off and expand and extend your storage solutions that are out there. Come to my Friday session that's coming up and talking about storage. I go into great, gory, detailed depth about storage spaces and the changes. And then also go through and take a look at the ability to go off and extend and talk to the different clouds that are out there. And with that, I'm going to say thank you very much for attending and joining us today. Please, 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 please evaluate and fill out those evaluations. Chance to go off and win a mouse, sculpt mouse that's out there.